Under the Occupational Health and Safety Act 2004, all employers have a responsibility to ensure a safe workplace. Safety is everyone's responsibility. Everyone involved in the construction industry has an obligation to ensure building and maintenance activities are carried out as safely as possible. This commences with the architects at the design specification stage and continues right through to manufacturers, builders, subcontractors and all workers involved in construction, and right through to maintenance. In Victoria for the past 20 years, and now used universally throughout Australia, New Zealand and Southeast Asia, Ausmesh 300 safety mesh has been used in conjunction with the ATF deck guardrail, roof edge and perimeter protection and roof access towers. This has been the preferred safety system used for fall prevention within the industrial roofing industry. Ausmesh 300 safety mesh meets the requirements of the Australian standards AS NZS 4389 and all relevant Australian state codes of practice. The Ausmesh 300 becomes a permanent fixture for the life of the building, providing the required safety working environment throughout initial installation and for any maintenance work in the future. Ausmesh 300 consists of 2mm galvanised wire with a tensile strength exceeding 450 MPa. The longitudinal wires are spaced at 150mm centres with cross wires spaced at 300mm centres. The rolls are 1800, 2100 and 2250mm wide and supplied in either 50m rolls or cut to length to suit various roof sizes. The trimming of cross wire ends has been designed to avoid hand injuries. Ausmesh 300 is also available with PVC coating for various applications. PVC safety mesh can be used for high corrosive areas such as aquatic centres and desalination plants. This mesh can also be used in areas where a decorative finish is desired for the underside of the roof. PVC mesh is available in rolls of either white or black. Ausmesh has done extensive testing to ensure that its safety mesh complies to the AS NZS 4389 standard. This standard requires a 2-metre wide test bed with 3 bays of purlins spaced at 1500mm. The test load consists of a sandbag approximately 1500mm long by 350mm in diameter, having a mass of 165 kilograms. The bag is dropped from a height of 1400mm. Testing has been done with our 1800mm wide and 2250mm wide mesh using both 1500mm and 1700mm purlin spacings. In this first test, we've tied off only every second strand to the purlins. As you can see by this failure, it's imperative to tie off every strand with at least 4 full turns as per the standard. In this second test, we've tied off every strand with 4 full turns to the required standard. As you can see, if installed correctly to the manufacturer's and standards recommendations, Ausmesh 300 will not fail and will arrest an accidental fall. Depending on the size of the project, the entire area of the roof frame should be meshed out before the roof is loaded with bundles of roofing material. Workers installing the mesh should be protected from falls with the use of booms, scissor lifts, mobile scaffolds or other approved systems for working at heights. The mesh, with the cross wire uppermost, is run out over the roof using a continuous rope system or wire pulley machine. Using a continuous rope system, Ausmesh 300 can be installed safely from scaffolding positioned at each end of the roof. An approved method for the placement of the rope, which pulls the first run of mesh across the roof frame, will be outlined in the work method and job safety analysis or JSA for the specific job. The wire pulley machine is a more efficient and faster way than the rope system. The wire pulley with the right frame can be used to pull our 1800mm wide or 2250mm wide mesh. The wire pulley machine uses a continuous rope system which is powered by an electric capstan winch. With the manual rope system, the rope has to be retrieved before you can pull your next roll. Once the winch is set up, it enables you to pull the wire across the roof frame at a rate of 1.6 metres per second. As with the rope system, scissor or booms are required on both sides of the roof. With a side lap of 150mm, stapling of mesh is only required if the purlin spacing is 1700mm or greater. In some circumstances, side stitching and double lapping is required, in accordance with local or state regulations. The preferred method of fixing the mesh to the purlins is to pass each longitudinal wire through a hole pre-drilled in the top of the purlin and tie off around the same longitudinal wire with at least 4 full turns. Every longitudinal wire must be fixed in the same way. Alternatively, instead of drilling, the wire can be wrapped around the purlin. With this method, every longitudinal wire is wrapped around the purlin, then tied off as when drilling into the purlin. If these methods cannot be achieved when fixing to a heavy steel beam or structure where pre-drilling is not possible, separate 3.5mm wires are looped around the beam or structure for each longitudinal wire. Each longitudinal wire is then looped through and tied off with 4 full turns. Where the wire is to be fixed to timber purlins, 40mm by 3.5mm staples should be used. Where it's necessary to make longitudinal joins, the knot and the tie should be the full length of the tail wire. This can be achieved by cutting the longitudinal wire as close as possible to the next cross wire, leaving a 300mm tail. This is to be done on each of the rolls being joined together. The tail wire should be tied at least 4 times around the knot. The other tail wire is placed under the longitudinal wire and tied around the cross wire. The join should be the full width of the mesh with every longitudinal wire joined. The box gutter, along with safety mesh, handrails and access towers, provides a safe working surface for the loading and installing of roof sheeting and associated materials. Box gutters should be installed in accordance with local regulations, standards and codes. Prior to installation, all brackets and supports associated with the box guttering need a load test certificate that conforms with load capacity. Only then does the box gutter support system become an integral part of the safe working surface for the purpose of installing roof sheeting. The box gutter support systems may be installed prior to or after the safety mesh is installed. General commercial developments require the box gutter brackets to be installed from below the roof frame using an elevated work platform or EWP. Pre-operational checks for the EWP must be completed and recorded in the operator logbook prior to operating any plant. If the EWP is of the boom type, approved harnesses must be worn in accordance with manufacturer's instructions. Box gutter support systems are completed by the installation of brackets, generally built from preformed folded sheet metal, securely fixed to the structure. Multi-rib support sheeting is then laid over the brackets to complete the continuous box gutter support system. Firstly, the preformed brackets are marked at the correct spacing on the roof frame, and high and low brackets are installed to correct falls. The intermediate brackets are then installed at the correct spacing. This provides full support and points for fixing of the multi-rib support sheeting. Once the brackets are complete, the multi-rib support sheeting is laid over the brackets and screw fixed in place to provide a safe and trafficable platform for use during the loading and installation of the roof sheeting and associated materials. When installing safety mesh, it is not recommended that box gutters be used. If, in exceptional circumstances, it does become necessary to use the box gutter to install mesh, roof workers must undertake a site-specific risk assessment to eliminate, as far as practicable, any risk to workers' health and safety. Safety mesh does not control the risk of perimeter falls or through penetration hazards. Therefore, Ausmesh 300 should always be used in conjunction with appropriate edge protection, guardrails or fall arrest systems and devices. Guardrails are used to provide effective fall protection at the perimeter of the building structure, the perimeter of skylights, or other fragile roof materials or openings in the roof structure. The guardrail system should be 900 to 1100 millimetres above the working surface. The nominal clearance between rails should not exceed 450 millimetres. Where the roof pitch is greater than the critical angle set out in the Australian standards, the guardrail must incorporate a toe board or mesh infill to prevent tools, materials or debris falling from the roof. A third mid-rail or infill panel must be installed where the distance between the mid-rail and the work surface exceeds 250 millimetres. The guardrail system must be designed to withstand loads not less than those set out in Australian Standard AS 1576/AS 1657, fixed platforms, walkways, stairways and ladders. For rare occasions when guardrailing is not practicable, other measures such as safety line systems, including travel restraint systems and fall arrest, may be used. Ensure that any safety line system is securely anchored to certified anchor points and is set up so that the lines cannot be severed on sharp edges. Check that the lines can be used without creating the pendulum effect in the event of a worker falling. Only after the installation of safety mesh and the roof edge and perimeter protection has been completed on the area to be roofed, can access be allowed to the access towers. The access towers should be located as close as possible to the load position of the first pack of roofing sheets. Prior to loading of the roof sheets onto the structure for installation, the entire roof area must be assessed and risk controlled to provide a safe system of work for all employees. The Code of Practice for the Prevention of Falls in General Construction provides reference for risk assessment and implementation of control systems to eliminate hazards associated with working at height. Control systems for falls from height can be developed using safety mesh, temporary handrails, access towers and box gutter support systems. The roof structure is now ready for loading and subsequent laying of the roof sheets. The procedure for loading and laying of the roof sheets is planned and documented in line with state or local codes of practice using the Job Safety Analysis or JSA and Work Method Statement WMS for each job. It is imperative that all roof workers receive the correct training and are fully qualified to perform the tasks outlined in both the JSA and the WMS. As a general rule, cranes are used to rig and load roof sheeting onto the completed meshed out roof frame. To achieve this task, crane companies provide the crane, along with a ticketed operator and ticketed dogman, to assist in the lifting and placing of roof materials onto the structure as directed by the roofing contractor. Access to the roof should be via access towers located as close as practicable to the load position of the first pack of roof sheeting. If the crane operator requires assistance at the ridge line to control the swing of the load, workers may gain access by walking up the main rafter of the portal frame. Obviously, this can only occur once the installation of safety mesh has been completed and is only allowed for the purpose of loading roof packs. Access between packs of sheets may be provided along the eave purlin using the guardrail to maintain balance. Following the loading of the roof sheets onto the structure, laying of the roof may proceed. Access to the packs of roof sheets is gained along the trafficable box gutters or eave purlins. The straps of roof packs are cut and the sheets are loose laid consecutively across the purlins. Once loose laid, the sheets provide a progressive platform for the installation of the sheeting and insulation. Where a gap is required between roof sheets for the laying of insulation, the gap should be kept to a minimum. The gap for the insulation is created when the first roof sheet is to be laid. The insulation is then laid over the purlins, any necessary clips attached, and then the roof sheet is placed in location and fixed to the structure. This process is continued until the roof installation is complete. The sequential implementation of this safety system for roof work is designed to protect all workers on roofs from injury or death from falls. Work can proceed quickly as workers can move around the roof structure with confidence and safety. Employers can relax in the knowledge that they are complying with their legal responsibilities and that the complete safety system will protect their workforce.